Okay, so this is an example that your book talks about, but I think it's important to make sure that you go over this because I know some of you haven't been reading the book as closely, and it's a good example of conservation of angular momentum. So let's imagine we have a person who's sitting on a stool here, and he's holding this wheel and it's spinning around with angular velocity omega. Okay, but then let's say the person flips the wheel. So then it's so that now when he's holding it here, he turns it upside down. So now it's spinning in the opposite direction. Okay. Um, well, we know that that's also going to cause the person to spin around, and they're going to be spinning around. You know, again, we'll choose the positive direction, the angle that they're spinning. So initially, our angular momentum was just the moment of inertia of the wheel times omega, its initial angular velocity. The final angular momentum is going to be the moment of inertia of the person, the student, times the his velocity around his center of mass, plus um, plus the mass of the wheel times this distance here. We'll call this RW, which is the distance from the center of mass of the wheel to its new axis of rotation. Right. This is a parallel axis theorem thing. So this is RW squared times the angular velocity of the student, and then minus I omega, the moment of inertia of the wheel times its initial angular velocity, because now again this one's spinning in the opposite direction. Okay, so we see that this is equal to the angular velocity of the student, his moment of inertia plus m omega rw squared minus I of the wheel omega. So in other words, the final angular velocity is the original is twice the moment of inertia of the wheel times its initial angular velocity divided by the moment of inertia of the student plus the mass of the wheel times its distance from the axis of rotation squared. And so this is a pretty neat effect. And so one of the disadvantages to having videos like this is that I don't have an actual video for you to watch. We don't have like a classroom demonstration. You can find this. You can probably find this on YouTube, and it's pretty cool to watch because it's really crazy that you can literally just be holding a wheel, flip it upside down, and all of a sudden, so in this case, the student would actually start spinning around. And so, so let's see. Hold on a second. Okay, so I was able to find a video real quick, and so you can watch and see. So all she's doing is turning the wheel, and as she turns it straight, she stops spinning, and then depending on the direction she's turning it, it's actually turning the girl, who's just sitting on a stool. And so you can imagine that this is kind of the basic principle behind a gyroscope, and it's also been used at times for people. You can in ways to design like a spaceship or steering something like a satellite. Because you don't actually even need rockets for it. All you need is just like a really heavy wheel that you can spin really fast, and that's going to allow you to to steer something and to turn it.